posted some homework. This is topic is nuclear physics. A nucleus emits a beta minus particle. What is the change to the proton number and to the nucleon number of the nucleus? So can you, I hope you have you remember that I had shared some sheets with you, with everyone actually, that are equations, if I can recall, beta minus decay.
So anti-neutrino will be formed.
Uh, this is the equation. So proton number is increased by 1. So either it is C or D. There is no change in mass number.
Then it is D.
Ali, can you hear me?
Can you hear me?
Yes, I can hear you. Yes, you were right. The answer is D. I was waiting you to join again. A neutron collides with the nucleus of uranium-235. One possible nuclear reaction that results is represented by the equation this, where X represents one or more particles. It appears to be a nuclear decay. It appears to be nuclear fission. It looks like a nuclear fission reaction. So we need to balance the numbers. There is a 235 plus 1 on the left hand side. If I can here, so it is 235 plus 1, 236.
So will they be like two neutrons because the nucleon number is changing? The proton number is the same.
No, I'm talking about 96. I think we should compare the total. The left hand side total is 236. What's the right hand side? 154 plus 80. Ninety-two is there. 154 plus 80. How much is 154 plus 80?
234.
So denominator is coming. Interestingly, denominator is already coming equal, and the numerator is that is 2. So denominator is 0. It means that mass number total should be 2 and charge is 0. What do you think if the charge is 0? Shouldn't be neutron if it is 0 charge?
It should be a neutron.
So it should be a neutron. There are two options for neutron. There are
Will
two
it be
options
C?
with A. Yes, because I need to get a total of so this is the idea. A neutron is composed of one up quark and two down quark. When the neutron decays to a proton, there is a beta emission, UDD.
Neutron to proton, does it give a beta minus, right? It will give a beta
Now,
minus.
this is I always tell my students that they should learn those very important two sheets, which I think, let me see, I think I had forwarded before paper 2. And
Yes, I like recalled it before going to the paper two. There was a similar question in it. I was able to do it like easily.
that's good now. I have posted that I'm trying because I'm facing an internet issue here today, and I have reposted it. That's a very important sheet, and you should learn it because it's very helpful.
Yes, for the beta plus is released when a proton is decomposed.
Hmm. I have reposted it, and that sheet is very important, very helpful. And now, if you remember that sheet, it is the symbol for a neutrino is VE and the antineutrino is VE bar. So this is a memory call. Straight away, a memory call. Neutron decays to a proton. So looking at those sheets, I've reposted them. Can you tell me the answer?
I don't have those sheets right now. I have a different like system.
I have posted you again just now.
Okay, I'll have to get that phone.
No problem. You can get it, and it's a good way to memorize it. Examiner says neutron decays to a proton. Neutron decays to a proton. So if neutron decays to a proton, it means neutron is UDD. So when it converts to a proton, it is UD. Did you get the sheet which I have
Mm,
posted now?
yes, I got it.
Good. I have written it again on the screen also, and this one sheet is very important, very critical, and it is a summary of actually many important features. Now you can tell me that what answer should I get?
There'll be an anti-neutrino in this one. Uh, Anti-neutrino. So it will be B.
So
It is
it
a
should
beta
be
minus
B.
an anti-neutrino.
So answer is B.
B, yes.
Which list contains only leptons. Leptons actually contains, leptons are fundamental particles like electron, like positron.
So will it be A?
I think it looks fine to me. Leptons. Hmm. A nucleus of magnesium 23 undergoes beta plus decay as represented by the nuclear equation shown. Let's write the fundamental equation for beta plus decay.
0 plus 1. And then a neutrino will be formed. So the proton number will become one negative and the mass number will stay the same. So will it become the
Uh,
option C?
do you mean that proton number is increasing by one
No, it will
or
decrease by 1.
decrease by one is right? Perfect. So proton number will decrease by one. So magnesium is 23, 23 will remain 23. So for I have C and D, and 12 becomes 11. What is the correct equation for beta plus decay? We have just written beta plus decay equation down. So what should be the answer for 92A?
So neutrino will be formed. So option A and C will be wrong. And beta plus happens
Option
in a
A.
proton. So D will be the answer.
Perfect. Some memory. Radon 211, francium 210, and radium 212 are three nuclides. How many neutrons does each nuclei have in its nucleus? I think neutrons, we should show the subtraction.
I think the answer is B.
Have you subtracted it?
Yes, because 211 minus 86 is 125. 210 minus 87 is 123. And the last one is coming 124. So D.
So the first is coming 125, second is coming 123, and 124.
Yes.
How many down quarks are in a nuclei of hydrogen 3? Now, this is a point to understand that hydrogen 3 means hydrogen 3 means 3 minus 1. Just excuse me for a second. So I have 2 neutron and 1 proton. Can you tell me what is proton UUD na?
Proton is UD. So 5 is the answer.
So if I combine them, I will get answer is coming D with the working I have shown. In the alpha particle scattering experiment, a beam of alpha particles is aimed at a thin gold foil. Most of the alpha particles go straight through or are deflected by a small angle. A very small proportion are deflected through more than 90-degree, effectively rebounding towards the source of the alpha particle. Which conclusion about the structure of atoms cannot be drawn from this experiment alone? Most of the atom is empty space. ये तो सही लग रहा है, ये तो उसकी logical explanation बनती है. Most of the mass of an atom is concentrated in the nucleus. ये भी उसी के. The nucleus contains both proton and neutron. The nucleus is charged. चार्ज होना भी प्रूव है, वरना डिफ्लेक्शन ही प्रूव नहीं होती. डिफ्लेक्शन से पता चल रहा है कि वो चार्ज है. तो अब देखो न्यूक्लियस में प्रोटॉन और न्यूट्रॉन दोनों हैं. ये उस वक्त डिस्कवर नहीं हुआ था. न्यूक्लियस पहले डिस्कवर हुआ. would be C. Which elementary particle is a lepton?
Leptons are like fundamental particles, right? It will be electron.
Electron is a lepton. Quark is not a lepton. So it should be a straightforward question. Which combination of up and down quarks form neutron?
Three.
Sorry, I'm unable to hear you. Actually, I think I'm having an internet issue. You said, acha, fine. Neutrons, UDD. Hmm. सही है. What is the core composition of a hydrogen 3 nucleus? We just done it, so we can look back. It looks to be a repeat question. And H31 we can see here 4U5D. Eighty 85. Each option shows the number of neutrons, protons, and electrons in two atoms, some of which are ionized. Which pair of atoms in the table are isotopes of the same element? Isotope means mass number should be the same. Mass number should be the same. Atomic number should be the इसमें we have which pair of atoms? C. My on my side, speaker is working fine. You can try to see if I can hear you.
Can you hear?
How you say it? Yes. Did you say something?
Yes, I was saying that it has the same protons, but
Uh,
not.
volume is your sound is coming very low.
Maybe it's a problem with the mic.
But your answer is right because atomic number must be the same. No problem. The diagram shows a sequence of radioactive decays involving three alpha particles and a beta particle. Three alpha and a beta particle. What is nuclide T? Acha, you have solved it, I hope, and it is 233. Yes, you are right. 84A, an astatine nucleus has a nucleon number of 218, proton number of 85. It decays to form a polonium nucleus emitting a beta minus particle and an alpha particle in a process. First one beta and then alpha. B. Okay. Yes, is B. Which particle is a fundamental particle? Fundamental particles are like leptons, because you're right, because electron is a lepton. During beta minus decay, which change takes place to the core composition of the nucleus that emits the beta minus particle, and which other particle is emitted? Again, this is the same situation that beta minus decay. If you see the same master sheet, right. A. Okay. What are the structures of the proton and the neutron in terms of quarks? Protons U, D. Okay, you say C. Is right. The nuclear equation shown has a term missing. It looks to be a beta minus decay. It looks to be a beta minus decay. Anti-neutrino. Huh. A certain nuclide uranium-235 has a nucleon number 235, proton number 92, and a neutron number 143. Data on four other nucleides are given below. Which nuclide is an isotope of uranium-235? Atomic number should be same. Everything is atomic number. 92. 92 is coming in one line. That looks to be a same atomic number here. A reactive nucleus is formed by beta minus decay. This nucleus then decays by alpha emission. First beta minus and then alpha. So which graph of nucleon number n plotted against proton number z shows the beta minus decay followed by the alpha emission? Is using nucleon number symbol as n. So I should update it. Normally at nucleon number is not A. Normally nucleon number is Z. But here he is using N. So it should be B looks fine because first mass number same. Which statement about alpha particles is correct? 76 is correct. Alpha particles emitted from a single radioactive isotope have a continuous distribution of energies. This doesn't look right. Alpha particles have less ionizing power than beta. This is definitely wrong. Alpha is more ionizing than beta. The charge of an alpha is this. This is in a television program to illustrate scientific models, a presenter fires a gun many times at a bale of hay. Two small cannonballs are embedded within the hay some distance apart from each other. The hay bale measures approximately this, and the cannonballs are made of iron, approximately spherical and about 5 centimeter in diameter. What might the presenter be illustrating? This is obviously an idea of alpha particle scattering experiment. No, 76 can I have highlighted it. Actually, the word single is giving a problem because many radioactive isotopes are able to emit alpha particles. Alpha particles travel at a good high speed. Now, 75. I have read it once. Two small cannonballs are embedded within the hay, some distance apart from each other. The hay bale measures approximately 2 by 2 by 2. Now, the idea is simple. It cannot be decay. It is not conservation of momentum. This is not a collision. Now, it can be either double slit or alpha particle scattering. So what do you suggest that the answer should be what? It is not beta decay. It is not conservation of momentum. Now, this experiment, now you have to remember that experiment should be compared with another experiment. A is right answer because it is similar to alpha particle scattering experiment. A nucleus of uranium-238 decays in a series of steps to form a nucleus of lead-206. An alpha particle, beta minus particle is emitted during each step. What is the total number of beta minus particles which are emitted? How many steps are there? 238. Acha, first we should subtract it, right? 238 minus 206. So 32 and 6. 6 beta particle, you mean beta doesn't change atomic number. So how you're getting it 6? If I subtract 4, 4, 4, हाँ, 8 alpha particle can be possibility because 32 upon 4. But we have to see, but you have to double check. 92 minus 16. Where is 92? Acha, Z minus 2. But when I was thinking that 238 minus 206, it's coming to be 32, and there is a possibility of 4 alpha. At maximum, it can be 8. 76 to 82. Acha. Maximum 8 alpha particle can be there, but he's asking for beta particles. If there are 8 alpha at maximum,
Can you hear me?
I can hear you now.
The thing I did was like I figured out that the 8 alpha particles emitted because of
Again, sorry,
kind of.
this our sound is very very cutting.
I'll rejoin.
All, I got your point actually, but I'm trying an approach that maximum there are 8 beta, but that doesn't fit. So the problem is there that because if he says that an alpha or a beta particle emitted during each step. So what I was thinking that at maximum, if I take all of them beta, I will get 8 beta, 8 alpha, sorry. Maximum, I will get 8 alpha, but in that case, how I will get 10? Because if there are 8 alpha, 10 is not possible. 10 beta, because this is no possibility, because how you fit that? 6 we can try. 6 beta minus. If I try 6 beta, right, perfect. So if I take 6 beta, that 92 that becomes 98. Sixteen alpha. A table lists the nucleon number and the proton number of various nuclei. The nuclei are represented by the letters L to T. Nucleon number is proton number. Okay. Which row in the following table correctly shows 3 nuclei of the same element? 3 nuclei have the same number of neutrons. So we have to subtract. We have to subtract for neutron. How much is 227 minus 89? So in this way, we can make a list of it. So let's try this. One 137, then 136. Okay, 137, 136. Thank you.
Uh, 137 6 are coming for M and N.
Acha, M and N. Acha, sorry, M and N. 137, 136. Okay.
For O, it is also 137, and for P, it is 136.
So we can go for, we can complete this and then we can answer the question. So if you can hear me, if you complete this list and then you can compare and get the answer. Yes, can you share the suggest the answer?
N, P, and R are having the same number of neutrons.
Okay, then
So
what
it is
should be the
A
answer? What
answer.
do you suggest?
A.
Right. So let's keep it up to here, and we will have class inshallah tomorrow, and we will continue. And the plan is same that